All right, for today's lesson, we're going to look at a very important rule that you're going to add to your differentiation toolkit, and that is what we call the product rule. In other words, whenever you have a function multiplied by another function, how do you take its derivative? So in other words, what would be the derivative of f of x times g of x? The rule says that you have the derivative of f of x times g of x would be the first function, f of x, times the derivative of the second function, g of x, plus the second function, g of x, times the derivative of the first function, f of x. So one way of thinking about it is first times derivative of the second plus second times derivative of the first. And that's how you find product, the derivative of product of the function. So, for example, let's say that I told you that I had a function and it was x squared times 9x plus 2. So notice that this is my first function, x squared, and this is my second function, 9x plus 2. Now, what's interesting, guys, is that you could actually find the derivative of this without doing the product rule by simply distributing this x squared, so you get 9x cubed plus 2x squared. That's not the derivative, that's just distributing that, and its derivative would then be 27x squared plus 4x. So you don't necessarily need the product rule to find this derivative. We can find it with it. So here's what my derivative would be if I use the product rule. Now I should get the same answer as I got over here. So what I'll do is first, so x squared, times the derivative of the second. Well, the derivative of 9x plus 2 would just be 9, plus second, which would be 9x plus 2, times the derivative of the first, which would be 2x. And so that doesn't look like the same thing, but if I clean this up, I'll get 9x squared, and if I distribute this, I would get 9x times 2, so that would be 18x squared plus 4x. Combine my like terms, I get 27x squared plus 4x. So again, we got the same derivative. But not all functions would require you to do the product rule. However, the product rule does work if needed. Let's take a look at another example. Let's say I gave you the function y is equal to 2 plus x to the negative 1 times x. Let me make that a little bit better. And then my second function is x to the 3 halves plus 1. And I ask you to find the derivative of this. So the derivative, y prime. Or if you want to put y dx, that's fine. So the derivative of this would be product rule. So this right here is my first, and then this right here is my second. So the derivative would be first, so 2 plus x to the negative 1, times the derivative of the second. Well, the derivative of x to the 3 halves would be 3 halves x to the 1 half. I'm going to clean that up just slightly because that doesn't look like a 3 halves. Clean that up so it's 3 halves. All right, so first I'm doing the second plus second, so x to the 3 halves plus 1 times derivative of the first, and the derivative of the first would be negative 1x to the negative 2. And so if I wanted to clean this up, I could, doing a little algebra. So I would distribute, and that would give me 2 times 3 halves. That would give me 3x to the 1 half plus 3 halves x to the negative 1 half. Then if I distribute this, I would get negative 1x to the 3 halves minus 2, that being negative 1 half, and then minus 1x to the negative 2. I notice I do have some like terms in the middle, so I'd have 3x to the 1 half, sorry, not 1/3, 1 half. 3x to the 1 half, and then 3 halves x to the 1 half minus 1x to the negative 1 half. That would give me plus 1 half x to the negative 1 half minus x to negative 2. And I think I will be fine just leaving it like that. So 3x to the 1 half plus 1 half x to the negative 1 half minus x to the negative 2. That would be the derivative of that function for that one. All right, if we look at another problem, let's say I ask you to find the derivative with respect to t of t squared. Let me write that a little bit better. That would put that in bracket. So t squared e to the t. If I ask you to find the derivative of this, it doesn't look like it's that difficult, but keep in mind that this is first, right? T squared is first, and then et, that's second. So by the product rule, the derivative would be first times derivative of the second. Well, thankfully, the derivative of e to the t is just e to the t. So first times derivative of the second plus second times derivative of the first, and that would be 2t. So then the derivative would simply be t squared e to the t plus 2t e to the t. There's a lot of t's right there. But that would be the derivative of that function. So again, the product rule is very, very much needed and useful for finding derivatives of products. And I'll do one more. Really quickly, I'll make one up. Let's say if I wanted to find the derivative, I'll keep it with respect to t. The derivative with respect to t of x squared sine, well, I can't do x squared if I'm doing it with respect to t, can I? So let's do t squared times sine of t. I ask you to find the derivative of this with respect to t. So again, identify what's your first. In this case, it's t squared. Identify what's your second, which in this case is sine of t. So the derivative of that expression would simply be first, so t squared. And so first, t squared times the derivative of the second, which would be cosine of t, plus second, so sine of t, times the derivative of the first, which would be 2t. So my answer, the derivative would be t squared cosine of t plus 2t sine of t, and that would be the derivative of that function. And I think that is it for this lesson. I'll do one more. Let's say that I want you to find the derivative of 2x cosine of x minus 2 sine of x. So this one's interesting. So if I wanted to find the derivative of this, first of all, I notice that there is a minus sign here. So let's just look right here. So what I would consider my first is this part right there. So there's my first, and there's my second. And I know the derivative of 2 sine of x. The derivative of 2 sine of x would just be 2 cosine of x. So that's easy, but over here we got to find the derivative. So let's take the derivative now. So I'm going to say the derivative. So the derivative of y with respect to x would be first, so 2x, times derivative of the second, which would be negative sine of x, plus second, so cosine of x. Let me make that a little bit better. So cosine of x times derivative of the first, which would be 2. So that's good. And what we said the second the derivative of 2 sine of x, so that would be minus 2 cosine of x. And then I can clean this up if I need to. So the derivative of y with respect to x would be negative 2x sine of x plus 2 cosine of x minus 2 cosine of x. And notice the 2 cosine of x minus 2 cosine of x crosses out. So then my derivative would just simply be negative 2x sine of x. And that would be the derivative for that function right there.